Hello and welcome to my next video in which I will show you how to test a Micronaut application with Kotlin. Today we will use JUnit 5, MockK, Rest Assured, as well as MicronautTest and MicronautTest resources. To be even more specific, we'll be working with a Micronaut application that exposes a REST API and connects to MongoDB. And if you would like to learn how to do that step by step, how to create such an application, then check out my other playlist on my YouTube channel. Lastly, I just wanted to invite you to my newsletter in which you'll get a weekly dosage of Kotlin on the backend knowledge. So, as I mentioned in the introduction, let's start everything by checking the project we will test today. Let's open up the project in IntelliJ, navigate to src, main, resources. Right here we'll see three application properties file. The main one, the one for Mongo, and the one for test environment. So if you've ever been working with Micronaut or even Spring Boot, then you know that these two will be only running and took into consideration when we'll specify the Mongo environment or in test environment. Let me open up the first one. We'll see that we have only the application name right here. Let me dismiss this window. Excellent. Next, let's navigate right here to the Mongo one. Inside it, we can see that we have the MongoDB URI to localhost 27017, which is the default MongoDB port, and the example database. Lastly, we have the test one where we specify the model package com.coderc.model for MongoDB. But why this way? Well, to avoid two issues. So let's start everything by explaining why don't we put the MongoDB URI inside the main properties. Well, as I mentioned in the beginning, we will be using MicronautTest resources, and when we use them, MongoDB support will start a MongoDB container and provide the value of the MongoDB URI property. Nevertheless, this will not happen when we explicitly set the URI in the application properties. And that's why we want to make this setting available only when we set the environment to Mongo. So whenever I will be working with tests, this one will not be taken into consideration. In your own development, you may want to specify the environment to Mongo to connect to this MongoDB database. Additionally, if we don't specify explicitly the package name where our model classes live, we are going to end up with codec cache key issue, which I will show you later. To me, it looks like a bug, but thankfully we can easily avoid that by simply putting the package names and point to where we put our model classes, our POJOs, right? Excellent. So next, let's navigate to Kotlin and let's open up maybe the model. Right here, we will have the app user, which is the entity stored persisting in the MongoDB and retrieved from it. We have a mapped entity annotation along with ID and generated value. So this value string identifier is generated automatically by MongoDB. Additionally, we have the address, which is annotated with serializable and deserializable. Similarly, we have two request classes, which are marked with deserializable. The app user request, which is used in post endpoint when creating new users, and search request, which, as the name suggests, is used to search for users. So as we can see, nothing spectacular here. Let's open up the repository. We have one repository, app user repository, which extends the CRUD repository. Additionally, we have two methods right here, find by first name equals, and the next one, find by first name like, which uses the Mongo find query annotation. That's not so important what exactly it does right here. If you would like to learn more, then I invite you to the playlist I mentioned in the beginning. Nextly, we have a service layer which injects the app user repository marked with singleton, and it exposes a bunch of methods like create, find all, find by ID, update, blah blah blah. All of the methods simply encapsulate the app user repository so that we do not inject that directly into our controller. And speaking of the controller, let's open up the controller package app user controller, we can see that we have a controller that responds to /users, and we expose a bunch of HTTP methods like get by ID, post/search, update by ID, and delete. We will not be testing all of them today. As a homework, if you would like to, of course, you can do that. Lastly, let's maybe take a look at the import. So let's open up build.gradle.kts file. And right here we can see the among other plugins, right, we can see the test resources that I mentioned in the beginning. When I scroll down a bit, we'll see two important imports. So the first one is MicronautTest Rest Assured, which is extension for the Rest Assured that we'll be using today. Additionally, we have imports for MockK and all the necessary imports that are required to work with JUnit 5 that we'll be using today. So basically, this is the whole project. Again, if you would like to learn how to implement step by step and learn a bit more about Micronaut, I highly encourage you to check out my other playlists where I do write step by step. Today, we will focus on the testing part. So, as the next step, let's start with simple Kotlin testing in Micronaut. So the first approach we are going to see will be a plain old unit test. But why? Well, because at the end of the day, that's what we will be dealing with most of the time. So with that said, let's open up test. And we can see that there is already one test. We can click on the com.coderc package, right mouse button, new package, and introduce the service package. Of course, when working with IntelliJ, you can do exactly the same. When you go to the app user service, click on the name, add plus, enter, and create a test. Right here you can see, set what testing library and things like that. So let's do it this way. Let's hit OK. Let's add this to Git. And we can see that such a class was created inside the service package. Of course, you don't need to create this service because if you create the test this way, this structure of packages will be recreated in tests. Nevertheless, let's start implementing our test. So the first thing I would like to do will be to simply mock the user repository. Private val app user repository equals MockK, and right here we must specify the type app user repository. Excellent. I made a typo. Let me fix that immediately. Repository. Now this is perfect. Nextly, let's introduce a app user service. Private val app user service equals app user service, and let's inject our mocked app user repository. Following, we can introduce the first test. So I would like to check whether the findAll method from app user service returns the empty list. So the first thing I would like to do, I must annotate this method with test annotation. Of course, this must go from the Jupyter API. Nextly, let's introduce our function. Fun should return empty user list. Excellent. So the first thing I will need to do will be to navigate maybe to app user service. Let's find the findAll, and we can see that this method invokes the app user repository findAll and converts the result to list. So the first thing we'll need to do will be to mock the app user repository call to findAll. Every app user repository findAll. Excellent. Let's import function from MockK returns empty list. Nextly, val result equals app user service. Again, the method, app user. Again, I made a typo here to Shift plus F6. App user service dot findAll. Lastly, I'll assert true that the result is empty. Assert true result dot is empty. Let me import function. The important thing is to select the right one, org.JUnit Jupyter API assertions. And lastly, when using MockK, we can verify that our BOK, app user repository, and the method was invoked exactly n times. So verify exactly 1. And right here, app user repository, and let's specify the call that we'd like to verify. When I hit Alt Enter, we must import from MockK, Ctrl Alt L to format the code, and let's run our test. So excellent, we can see that our simple JUnit test succeeded, and we are not going to spend much more time here. I have other resources about MockK and how to test with that if you'd like to learn more about this topic. For now, let's focus on the Micronaut specific testing. So as the next one, I will show you how to perform integration testing with MicronautTest. So let's start everything by explaining what exactly is the Micronaut test. And to do so, let's open up the test that was generated automatically when we generated the project, because we can see right here that it is annotated with Micronaut test. Well, so in simple words, it is an annotation that we can put on the test class to mark it as a Micronaut test. Yeah. You haven't expected that. I'm kidding. In practice, it means that when we run a test with that annotation, it will run a real application. It will use internal Micronaut features with no mocking. So at this point, we can clearly see that this will be the annotation for integration testing. Moreover, this annotation can be used not only with JUnit 5, but also with Spock, CoTest, and CoTest 5. The only thing that matters here will be the import, because they differ. Nextly, let's figure out MicronautTest configuration options. So this annotation allows us to configure a few properties, like the environments that we want to run our test with, the packages to scan, or whether the automating transaction wrapping should be enabled or not. So for example, let me show you. If we would like to run particular tests with a particular environment, then we can use environments, and we must to provide the array, for example, environment 1. So this is useful whenever testing some conditional logic or some logic dependent on the environments, right? Just like, for example, we had these properties here. As I mentioned previously, we can set the packages to scan. So if you would like to specify the package com.coderc package 1. Lastly, you can set, for example, the transactional true. Of course, I highly encourage you to check out this annotation to see its all capabilities. In IntelliJ, you can do that really easily. Just hit Ctrl, keep it pressed, and click on the MicronautTest annotation. Right here, download sources to fetch the documentation. And now you will see what exactly you can configure here. Excellent. So as the next step, let's figure out what are Micronaut test resources, and let's prepare the ground for the first test that will be no mocking, right? So let me do that manually. Let's click on the package, right mouse button, new package, controller, again, right mouse button, new Kotlin class, and let's call it app user controller test without mocking. Excellent. Let's hit add. And firstly, let's annotate that with MicronautTest. Wonderful. So what are these Micronaut test resources? So basically, they integrate seamlessly with test containers to provide a throwaway containers for testing. But we need to remember that test containers require Docker API compatible container runtime. So in simple words, we must to either install it locally, install the Docker locally, or use the test containers cloud. So in our case, we would like to do the integration tests that require MongoDB. So what options did we have here? We could use the real database, which sometimes may be the case for you, provide some H2 database, not the very best approach, or integrate test containers, which is the preferred approach when testing with Micronaut. And as I mentioned in the beginning, let me show you this once again. The only thing to integrate test containers with Micronaut is simply to add this plugin test resources. So right now I must start the Docker desktop. In my case, I'm using Windows, so that's why I'm mentioning Docker desktop. In your case, you should start the Docker instance as well. And with that said, let's add a simple test case with rest assured that will figure out whether the get/users endpoint returns 200 OK and verify the headers. So first thing, again, we must start with test, fun, and let's specify the name, should return 200 OK on get users. Should return 200 OK on get users. Nextly, I would like to inject the request specification, and that's why we added the library that supports rest assured in Micronaut. Spec request specification. Excellent. Let's open up the test. So right now we'll use the spec to query spec dot when, and unfortunately in Kotlin when is the keyword, so that's why we must use these. Nextly, let's simply specify get and the URL which we would like to query /users. Nextly then, status code 200 OK, this is the expected status code, and the header I would like to expect that the controller will return content type application JSON. Header, the header name content type, let me put it here, application/JSON. Control Alt L. Let's figure out once again what happens here. So firstly, we annotate with MicronautTest so that we start the integration test. Nextly, we annotate our test case with test annotation, and we inject the request specification, which is the extension for Micronaut here. Then with this specification, we can simply perform request the easy way. Let's run this test and see what's going on. Unfortunately, this step may take some time when you're running for the first time. The following ones should be faster. And excellent, we can see that the test passed, which indicates that everything is running as expected. Additionally, when we go to logs, we'll see that test resources service is up and running too. So following, let's add a similar test that will verify that when we are querying the /user/id endpoint, then we are getting 404 not found. This will be a good proof that entries inserted to MongoDB in other tests do not affect other tests. So the easiest way to do that, simply select this, Ctrl+D to duplicate, and let's change the name, should return 404 not found, on get user by ID. User by ID. And right now, I would like to delete the header assertion. Status code that I expect is 404. And right here we must specify the valid UUID for MongoDB, which will be 24 characters long. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1. I bet this is 24 characters long. Let me run the test. Excellent, we can see that this one passed too, which indicates that this endpoint returns 404 not found. Nextly, let's take a look at a more complicated example and let's see how to extract a JSON array in REST assured and how to assert that the array list is of some type. So again, this is not a REST assured tutorial. I would like to show you a bunch of the most useful things with which you will be able to start working on your Micronaut project. But if you would like to maybe learn more about REST assured, then let me know in the comment section and we'll do something about that. So the next test should create a user, so we'll use the post endpoint this time. Test fun should create a user. Similarly, I would like to inject the spec and let's open up the function body. The first thing I will need to do will be to instantiate the app user request. So val request, because this is what we use to query our post endpoint, app user request. And right now, the easiest way I think is to hit Control, open up this, hit Control and keep it pressed, and you can Control+C all of these. Now we'll simply provide values. Piotr. Last name, let's make it equals Volak. Email will be contact@codersy.com. Street will be some equals street. City equals city. And code was the integer value. 1, 2, 3, Ctrl-Alt-L, let's format this one. Nextly, I would like to hit the post endpoint and verify that the return status code is 2-on-1 created. Spec when, let's specify the content type header, content type, and the content type will be JSON. Body, as a body we'll specify our request, post /users, then, and status code, as I mentioned, 201 created. Following, I would like to hit the user's endpoint, get the list, and verify that it contains exactly one element, and additionally extract the list. So I will show you how to convert the responses from REST assured to Kotlin objects. And this is a useful one. You will see how to do that with a list, which is slightly different. So val list equals spec when get users. Then first, the status code I expect is 200 OK. Body. And right now we can use the size is 1. So let me firstly find the core matchers or .hamcrest.core matchers. So what it does, it simply takes the JSON array and verifies whether its size is equal to 1. So this is our first assertion. Following, we go with extract, so that we will extract the response payload into our list. So right here, again, as. Unfortunately, as is also a keyword in Kotlin, that's why it looks how it looks. Object type ref. And right now, list app user, let's specify constructor and empty body here. Excellent. So with extract as, we expect that we'll get a list of app user, and this list will be assigned to the list variables. So following, I would like to simply use JUnit and make an assertion. So right here you can see two options. You can go with size, or you can convert that to Kotlin objects and make the standard assertions you do with JUnit. Assert equals, and right now I expect 1 to be equals to list size. Import function. Nextly, if this is 1, so I can get the created user. Created user equals list dot first. And lastly, let's compare that first name equals to what we sent, and let's do the same to street. Assert equals, and right now request first name, request first name should be exactly the same as created user first name, created user dot first name. Lastly, assert equals and request dot street should be exactly the same as created user dot address dot street, created user dot address dot street. Control Alt L. Excellent. So let's run this test. Let's wait for a second. Wonderful. This test succeeded too. So a quick recap. We create app user request, we hit with post, we specify the body. We must, when using the post endpoint, we must also specify the content type that we are sending. In our case, this is JSON. We expect 201 created. Following, we do the next request. So you can see that you can make multiple requests as a one test. And we do two assertions, two ways of assertions. The first one inside the body, so you could stop right here if you would be interested only in the size of the JSON array, or alternatively with extract as, we can extract the Kotlin object and make the standard assertions just like we did right here. So excellent. As the next step, let's add 3 Kotlin utils methods that I find useful when working with rest assured. As we saw previously, we must use the backticks with when and with as. So to avoid that, let's introduce 3 extension functions, whenever and extract as, that will be helpful when working with tests. To do so, let's hit com.coderc, right mouse button, new package, and let's call it util. Nextly, I'll create a new Kotlin file and call it test util, okay? Let's hit add. And the first function I would like to do will be whenever. So fun, request specification. This will be the extension function called whenever. And it returns request specification. Request specification equals this when. So after that, we can get back to our test. And instead of using that and using backticks, we can use whenever. Just like here, we can do that exactly here. Excellent. Lastly, instead of extract as blah, 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 we can use extract as. So I would add 2 functions. The first one will be used for typeref, and the next one will be for the class type, which we'll be using in our next test. So fun. This will be a generic extension function, and validatable tabular response dot extract as. It will take the typeref of type ref type. And again, we specify .t equals this extract as, and we specify the type as typeref. Similarly, let's do for the class type fun t validatable response dot extract as class of type class t equals, and this does exactly the same, this extract as, and this time we simply specify the argument of type class. Wonderful. As the next step, let's get back to our test without mocking. And as a pro tip, let's see how we can inject the information about application context or reference the server that is running. In order to do so in Kotlin, we can use the inject private late init var context and application context. Similarly, inject private late init var server embedded server. So sometimes it can be useful, and as you can see, we can simply inject these two using the inject annotation from Micronaut. After that, let's see how we can skip test execution. But why we would need that? Well, the integration tests sometimes can take a lot of time, and the bigger our project becomes, the bigger the chance they are becoming annoying to you when doing standard development. And because of that, generally, it is a good practice to somehow separate them from the faster unit tests. When testing in Micronaut, we can easily achieve that using the requires annotation. So let's specify requires here, and this env, and let's call this integration test. So from now on, this test will be run only when the integration test environment is available. Let's hit run. And as we can see, all three tests were ignored. In a moment, I will show you how to set the environment as an example, but I just wanted to say that MicronautTest annotation turns tests into beans, and that's why we can use the requires just like we would do that in simply any singleton or bean that we would be creating in Micronaut. So there are a bunch of ways to set the environment in Micronaut, one of which is to simply go to IntelliJ, edit configurations. Let's see our configuration, and right here we have environment variables. So we can set the Micronaut environment variable, Micronaut underscore environments equals integration test. Now, when I hit run, right here on this exact one, containing Micronaut environments matching integration test, yep, we can see that 3 tests passed, nothing was skipped, which proves my point. As the last thing in our tutorial about testing Micronaut, let's take a look at how we can mock things using the MockK library. Could we use MockK? Yes, however, I found MockK better for Kotlin thanks to its DSLs. So let's create a new test in the same package. Let me navigate there. New Kotlin class app user controller test with mocking. Add MicronautTest. And right here, I would like to simply mock the repository. So we do not query directly MongoDB, but instead we'll be returning dummy data, mocked data from the repo. Private var repo of type app user repository equals MockK, and as the type app user repository. Excellent. And in order to mock a bean in Micronaut, the only thing we need to do is to annotate the method / inner class with the mock bean annotation. So let's do that. Mock bean. We must specify the type that we are mocking, app user repository, fun, app user repo, and this should app user repository and refer to our repo. Why I am doing this way? Because I would like to easily refer to the repo later in our test cases. So as you can see, we define that inside our test class, which means that this mock app user repository will be limited only to tests defined in this class. So we can simultaneously use both tests with mocking, without mocking, and they will not interfere each other. So lastly, let's write a bunch of tests to verify a few cases. Firstly, test, and let's figure out whether 200 OK is returned from the get users endpoint. So let me actually get back to the previous one. Let's copy this test, Ctrl+C, inject it right here. And additionally, we must mock the repository. So every repo.findAll returns empty list. Ctrl-Alt-L. Let's run this test. Let's wait a second. Wonderful. Following, let's add a test in which we verify the returning user by ID, and also I will show you how to work directly with JSON fields instead of extracting. Of course, I forgot about using our beload whenever instead. So test fun should return user by ID. Again, spec request specification. And firstly, let's introduce some found user. So val found user equals app user. It has the ID 123, first name Piotr, last name, let's say Volak, email equals contact@coderc.com, address, this will be a new object, address, and this object will have three fields, street, city, and code. Street equals street, city equals city, code, again, this was the integer value, so we have some found user. Now I would like to mock the repo call, repo.find by ID, and we can see this one returns optional. So here returns optional of, and the value will be our found user. When we are looking for 1, 2, 3. Lastly, let's do exactly the same what we did. Spec whenever get, and this time users /123, then status code. I expect this to be 200 OK, and following I would like to do a bunch of assertions to the returned JSON payload, and we can do that directly inside the body, just like we did with a list. Body, here ID equal to 1, 2, 3. Import function core matchers. Ctrl+D. Similarly, first name. Let's make sure that this is Piotr. And if you would like to access the inner object in the JSON, the simple thing address.street, and the street equal to street. Let me go, copy the value. Here we go. Let's run this test and see that everything is working perfectly. Yes, it is. So right now, let's copy this test and see that we can do exactly the same, but this time using extract. So using extract, I'll leave the found user, the logic responsible for mocking, instead of the body. Extract as app user class Java. This returns a new instance, so user. And now assert equals found user and the user. Let's import Ctrl-Alt-L, and this time let's run this one. Excellent. So similarly we could do for the rest of cases. I highly encourage you to do that as a homework. We have a bunch of methods right here for getting, fetching, updating. So I highly again encourage you to do that as homework so that you will learn a bit more. Of course, this is not the rest assured tutorial. There's a bunch of more interesting things in that library, and I think you should be interested in figuring out more about it. And that's all for this tutorial on how to perform testing in Micronaut with Kotlin. Together we've learned a bunch of interesting things which I hope will be useful in your projects. Again, in the description for this video you will find links to the codebase and other interesting Micronaut resources if you would like to learn more. That's all for this video. Let me know your thoughts in the comment section and see you in the next ones. Bye!